Okay, welcome everyone to our day two Alex Go To training. My name is Professor Terry Clark, and I'm going to be the host for this Go To training. Today, we're going to talk about decimals, percents, and fractions. Okay, so we're going to get started with adding and subtracting decimals. Okay, decimals is a very important concept in math. Does anyone know why decimals are so important for us to learn? Okay, guys, why do you think it's so important for us to learn about decimals? Okay, Rebecca saying because they're used every day. How about everybody else? That's definitely true. They are used every day. Okay, we need some more input from the class. Why is it important? Okay, for exact measurements. Okay, excellent. And for money. Okay, great. Okay, so we kind of hit it right on the head. Okay, when we're dealing with money, we've got to know decimals. Also with measurements, Norma mentioned measurements, which is very important. Our metric system deals with decimals. Okay, and we do use them every day. We see decimals around us. Every day almost in everything that we use and see. That's why we have to learn about them. Okay. Now we've got some algorithms or processes that we use for different operations. Okay. Does anybody know the rule for adding and subtracting decimals? Okay, so how do you guys think we add and subtract decimals? What are some steps to coming up with the right answer? Okay, excellent, Jennifer. You got to line up those decimals. Yep, yep, and yep, for me too. Yep, so we got to line the decimals up. So that's one of the most important things. Okay. Actually, Rebecca, with counting the number of decimal places, that's something that we'll see when we're multiplying decimals. Okay, so let's look at a problem that's going to involve adding and subtracting of decimals. Okay, now the problem that you see on my PowerPoint, okay, is going to involve negative numbers or what we call signed numbers. Okay, these are not really integers because integers are positive and negative whole numbers. These numbers are not whole, so they can't be integers. They're actually what we call signed numbers when they're positive and negative numbers, period. Because you can have signed numbers that are fractions. It could, like -1/4 is not an integer, it is a signed number. Okay, so these are signed numbers, but signed numbers, like integers, follow the rules for integers. So we've got to know two rules when we're solving this type of problem. We've got to know the rules for integers, even though they're signed numbers, and we got to know the rules for decimals. Okay, one of the things we're going to do is we're going to look at the rule for integers. That rule's listed below for us. If the signs are the same, we add the numbers, and then we keep the sign that is in the problem. So really what we're going to be doing in this problem is just adding 43 cent, a negative 43 cent. And if we were to look at that other decimal as money, what would that be written as? Okay, yes, that's correct, John. 20 cent. So the second one's going to be 20 cent. Even though there's not a zero behind it, it's actually 20 cent. It's not 2 cent. Okay, so we're looking at 43 cent and 20 cent. That's got to be added together. Now we can almost do that in our head. Okay, but we want to follow the rule, and then math practice makes perfect. So that's going to be the process. We're going to practice here so that we can get perfect. Okay, so we got 43 and 20 that get added together. Okay, and so because they have the same sign, we're adding them. Now notice how we're making sure that those decimals are lined up vertically. Okay, and then we're going to add the same digits that are in the same place value, because that's a basic definition that will always hold true to. You can only compare apples to apples and oranges to oranges. So we have to add things that are like, you add pennies to pennies and dimes to dimes. Okay, and so when we add this up, we're going to come up with 63 cent or 6,300. Okay, now we're still not finished here. Okay, so what do you guys think our last step's going to be here? That's correct. We're going to put that negative sign there. You guys are on top of things. So we got to drop our negative sign in front of the 63. So our final answer is going to be a negative 6,300. Okay, and once again, this problem involved two rules. It involved the rule for adding and subtracting decimals, and it involved the rules for integers. Even though we said these are not integers, okay, integers are positive and negative whole numbers along with zero. These numbers are not whole, so these are a different type of number. These are called signed numbers. Okay, so we got a different problem here. Okay, we've got 5900 minus 1. Okay, so I want you guys to solve this problem. Okay, let's see if we can come up with the correct answer here. Okay, let's see. Julie and Sean has negative 41 cent or negative 4100. Okay, those two things mean the same thing. We're looking at as money as 41 cent, negative 41 cent, and we're looking at as a decimal, which is negative 4100. Okay, how about everybody else? We've got 10 people in this go-to training. We got 2 responses. Okay, John has the same. Okay, so does Jennifer. Okay, everybody else, what are the rest of you guys got? Okay. Okay, thanks, Norma. That's a honest answer. Okay, so we're going to look at this. Now, one of the things I want to look at here, if we're going to look at this as integers, notice how we made this a positive, and then we made that a negative 1. Okay, so we could actually subtract 59 cent from a dollar. We could do that. And that's how we would come up with the 41 cent. But look at this rule down here at the bottom for integers. It says if the signs are different, we're going to subtract, and then we're going to take the sign of the higher absolute value. Okay, so the 1 is larger than the 59 cent. So that's why the ultimate answer is going to be a negative answer. Okay, so um, let's look at it played out. Um, we put it as $1, and we've got 59 cent. Now we're subtracting because the signs are different. Okay, we make sure our decimals are lined up, and then that gave us 41 cent. But the rule says that we take the sign of the higher absolute value. The negative 1 is higher than the positive 59 in terms of absolute value. Okay, does anybody know what that word absolute value means? I mean, because we got it right down there in the definition, and then I keep saying that word absolute value. What does that word mean? That is correct. That is a really good answer, Sean. It is the value of the number without giving the sign positive or negative. So we took away the sign and we looked at the number itself or the digit itself. That's going to give us so that's a really good layman's term. Okay. Now, the math or the textbook term for that is a number's distance from zero. So the further a number is away from zero, the larger its absolute value. But the truth be told, Sean, I like your definition a whole lot better. Take away the sign and look at the value of the number without the sign. Okay, so we take away the negative and take away the positive, we've got 59 cents and a dollar is clearly bigger than 59 cents. Okay. So from there, we went ahead and we subtracted. Now, because the dollar was bigger than the 59 cent, answer takes on the sign of the dollar, which made it a negative 41 cents. So you guys did an excellent job on that problem. We all came up with the correct answer. Okay. The nice thing about working with decimals, you can always think about money. Okay. And that will help you to solve these problems uh, quicker. Okay, so we line up the numbers. Here's the rule again. We've got one, two, three, four decimals here. So we're going to line them up vertically. Okay. Then once they're lined up vertically like that, we're going to fill in all of the blank spots with zeros. Okay. We can get away with that as long as we're working behind the decimal. Can't get away with it in front of the decimal, but you can definitely get away with it behind the decimal. Okay. From there, we're going to start adding according to the place values. So we just go 0009 is 9, 0050 is 5, 1 and 3 is 4, 1 and 2 is 3. Everything's lined up. Our final answer is 3 and 459,000. Okay. Now notice when I said that word and, I said that word and because of the decimal here. Okay, so the word and is another word that means there's a decimal. So 3 and then I read the number behind the decimal is 459. And then I took that last place value right here. That's the thousandth place value. Okay, so at the end, that's a thousandth. So that's the way it gets stated. Now I'm not going to write out the word. I'm just going to put TH here just to make it easier for me. Okay, but technically I'm supposed to write the word out. So that's 3 and 459,000. All right. Okay, so now we have a real world application. Okay, I want you guys to read this word problem and then everything that we just talked about in reference to working with decimals, adding and subtracting, I want you guys to solve this problem. And then while you guys are solving this problem, think about the key terms or concepts that's going to let us know whether we should add or subtract because we want to talk about those. Okay, so we got some quick answers here. At 4 and 62 hundredth of an inch. Okay, so we have 4 and 62 hundredth inches. Okay, so that seems to be pretty synonymous across the board. Okay, now what operation did you guys use to come up with that answer? Okay, subtraction. And what was the key word that let you know that you needed to subtract? Okay, so we have takeaway, yep, or cuts away. Okay, so the word cuts away and takes away means the same thing. Okay, see right there, cuts away. So cuts away and takes away means the same thing. Okay. All right. What about in the question? Do we see a key word in the question? Another a word that let us know that we should. That's excellent, Julie. Remaining. Okay, so remaining. That's another word that we're gonna see here. And thanks, Priscilla and Norma, for adding that in as well. Okay, that word remaining. So we see that word too. So those are those key terms and concepts that were or buzzwords that we're looking for. That's going to let us know uh, how we should go about solving this problem. Okay, and whenever we're working with word problems, we're always looking for those key words or concepts. In this case, we're looking at cutaway and remaining. Okay, so we've got that 7 inches. We're going to go ahead and convert that to a decimal, fill in those zeros, and now we're ready to perform our math. Okay, and of course, as you guys stated, cut away, which means the same as take away, and then in the question, remaining lets us know that we're going to be subtracting here. Okay, so we're going to go ahead and subtract. Okay, now in this case, we obviously start from the far right to the lowest place value, which is the 100th place value here. We obviously can't take 8 from 0. Okay. Does anybody know what math concept we're going to use in order to complete this operation? Borrowing. That's correct. Okay, so we're going to borrow. Okay, and then and we'll see that a lot in math, borrowing and carrying. Okay, a lot of times when we're adding, we're going to be carrying to the next place value. When we're subtracting, we're going to be borrowing. Okay, so we're going to have to borrow. We're going to have to borrow a lot in this problem because we can't borrow from the other zero. Okay, so the way the borrowing is going to look is we're going to, let me see if they'll do it for us. No, they just gave us the answer. I want to look at this. We're going to borrow one from the 7 and make it 6. Okay, now when you borrow, it goes away. So we borrowed one, and then we added it to the 0, and that made it 10. And then we're going to borrow one from the 10, and that's going to make that 9. And then we're going to add it to the last place value. So now we're ready. So now we're looking at 10 minus 8 is 2, 9 minus 3 is 6, and 6 minus 2 is 4. And so that's how we came up with 4 and 62 hundredths. That's a good job. Everybody did an excellent job solving this problem. Okay, so now we're ready for multiplication of decimals. Okay, and we talked about this a little earlier. I'm going back up to try to see who mentioned this rule for us, but somebody came up with this rule a little bit earlier uh, that dealt with the counting of the numbers. Yeah, that was Rebecca who came up with that rule earlier, where she talked about where we're going to have to count the numbers behind the decimal. So we're going to see that with the multiplication of decimals. Okay, so Rebecca was a step ahead of us, but now we've all caught up with her. So here's multiplication. Okay, so the first step is we're going to multiply the numbers together. And then we're going to do, as Rebecca mentioned, we're going to count the numbers behind the decimal. How many numbers are behind the decimal in this problem that I have on the PowerPoint? Okay, so Jennifer says there's one number behind the decimal. Rebecca has two. Sean and Norma has two. Okay, Cassidy has two. Okay, uh, yeah, that's right. There's one behind each, but we have a total of two. Okay, so we got a total of 2 here. So the 3 and the 4, that's going to make 2. But yeah, Jennifer, each has 1 each. But we have a total of 2. Okay, so if we have 2 numbers behind the decimal in the problem, what does that mean for us? Okay, so the answer will have 2 numbers behind it. That is correct. The answer will have 2 numbers behind it. So if the problem has 2 numbers behind it, as far as the decimal is concerned. So if the problem has 2 numbers behind the decimal, then the answer is going to have 2 numbers behind the decimal. So we're just going to multiply 13 times 34. And we're multiplying as we normally do. We start with the 4, multiply 4 times 3 and 1. That gives us 52. Then we multiply, we drop a 0, or we could say 30 times 13 and come up with 390. And then we add the numbers up. That gives us 442. Okay, and here's the trick. We've got 2 here, so we've got to have 2 here behind the decimal. Okay, and there we see it right there. So that's 4.42. Okay, so this problem is going to be a little bit more trickier than the other problem we did. The other problem uh, just had 1 operation in it. This one's going to have a few, so just be aware of it. Okay, I want to see if you guys can figure this one out. Once again, we're going to look for those key concepts, those buzzwords that are going to let us know what operations to perform. Okay, you guys are going to try to come up with the answer, and then let's be prepared to discuss the keywords or concepts or buzzwords that let us know what we need to do to come up with this answer. Okay, so let's see. Jennifer has $79.05. Okay, and as the rest of you are working through this problem, I would just like to remind you to take your time. Okay, in math, it's important to take your time. We got an hour and a half. So whatever we get, we're going to get it right. Okay, Cassidy has $51.25. Julie has $53.55. I can't wait till we start talking about these keywords or buzzwords to let us know what operations we performed. Okay, we're not going to rush the process. We're not going to rush the process. Okay, John has $53.55 as well. And Sean has $53.55. Okay, so Jennifer's recalculated her problem. Jennifer, that's a good practice. Okay, we always want to double check our work. Okay, Vandalia has $53.55. Okay, so we're coming in with a pretty consistent answer of $53.55 here. Okay, so Norma's still working on it, so we're going to give her a chance to finish up. Okay, as Norma's finishing up, I want you guys to start looking for those keywords and thinking about the words that let you know what operations you needed to perform. Okay, not a problem, Norma. That's an honest answer, and that's the most important thing. Um, while you were working on it, Vandalia gave us in addition and per minute and total. Those were the key words. Okay. What words let us know that we were to add? Okay. Okay, so Jennifer's saying that per means to multiply. Okay. Okay. Addition, yeah, definitely means to add. Total is another word that lets us know that we need to add. Okay, so we've done an excellent job of finding those key concepts or buzzwords. I like to call them buzzwords, and I call them buzzwords because when they see them, they make me buzz inside because now I know I'm going to be able to solve my problem. I see that word addition there. I see that word per there, and I see that word total there. Okay, so now I know I'm adding and multiplying to solve this problem because these words have told me that that's what I'm going to be doing. That word per means that you're going to be multiplying the 7 cent by those minutes, and you're going to be multiplying that 12 cent by those minutes, and then you're going to be adding those two things with that $12.33. Okay, and so here's our problem. Now, can I ask you guys a question? Why do you think we put parentheses around the 7 cent times the 510 and the 12 cent times the 46? Why do you guys think we did that? Excellent, John, because we want to do those first. Okay. Anytime we want to do something first, we put parentheses around it. That's actually the order of operation. Okay. In order of operation, we always do parentheses first. Okay. So if we got a formula, let's say we look at something in the real world and we determine that something needs to be added before it needs to be multiplied or divided, we put parentheses around it. And then what we're saying is that that needs to be done, first before anything else is done. So that was excellent. John came up with that. we're going to do that first. Okay, so in this problem, we're going to multiply the 7 cent times the 510 first. Then we're going to go and multiply the 12 cent times the 46 second. Okay, once we come up with those answers, okay, then we're going to take those two things and add them to the $12.33. Okay, because really when we did that first, right in here, we came up with 35, okay, 70. Yes, that's correct, David. And we're just going to add at the end. And then we got 552 here. Okay, so we can see it being stretched out here. Okay, and so now all three of these things here, here, and here are just getting added together. And then that's how we come up with the $53 and the 55 cents. So you guys did an excellent job of solving this problem. Okay, this go-to training is loaded with a lot of math wizards. I see that. You guys have come with your math hats on today. Okay, so we've got, one more rule for decimals. Okay, we've got three rules. Adding and subtracting has the same rule. Multiplication has its own rule, and dividing has its own rule. Okay, so we're going to look at the division. Okay, now with the division, we're going to have to work with long division. Okay, does anybody know the steps, the 4 steps for long division? Okay, what's those 4 steps that we got to use for long division? There you go, John. Divide, multiply, subtract, and bring down. Excellent. Divide, multiply, subtract, and bring down. Those are the 4 steps. Okay, so in math, we're going to see that a lot. And I'm just going to type them in there, subtract, bring down. Okay, now you're going to be working with long division in your assignment 1. Okay, so you'll have a problem um, like they may say, um, I'm going to do something here right quick before we talk about the rules for this, because I just want to touch on something. Okay, so let's say you got 7 feet. And then we multiply that by, I don't know why I put that there. Push it back. Okay, so let's say we got 7 feet. And then we're going to multiply that. We're going to increase that by 1.24. Well, actually, I don't think there'll be any division in this. I don't know why I pulled that up. I digress. Forget what I just said. Okay. If it surfaces again, then I'll address it. Let's just stay on course and work with dividing the decimals here. I thought maybe it might surface in assignment 1, but the more I think about it, I don't think that's going to be appropriate to do it there. Okay, so here we've got 1.16 divided by 2, and then we've got 23.6 divided by 4. Okay, now we've got some rules we got to remember. Okay, there are 4 components to a division problem. Okay, so one of the things I want to do is I'm going to take the 2, and then I'm going to take 1.16 here. Okay, and then I'm going to label some stuff for us. The 2 is going to become the divisor. Okay, that's the name of it. It's the divisor. It's the thing divisor. It's the thing that's doing the dividing. The divisor. Okay, the 1.16 is the thing that's being divided. That's the dividend. And then the answer, and I'm just going to put the word answer here for now. That's going to be the quotient. Okay, and that's math talk. Okay, and that's going to be important because when we start talking about what we're going to be doing and what we can't do with the rules, ultimately we're going to talk in math talk. Okay, all right. So, okay, here's the math talk. Okay, there cannot be a decimal in the divisor. Okay, so there can't be a decimal in the divisor. So let's say if we had something like this right here, 2.17, like that. And we're not going to do this one. I'm just putting it here just to define the rule. 8.2 like that right there. Okay. And then I'm going to put what I just said in the chat box. There can't be a decimal in the divisor. Okay. So there can't be a decimal in the divisor. So that brings us to the next step. If there is a decimal in the divisor, we must move the decimal out of the divisor. Okay, so that's the second thing. There can't be a decimal in the divisor. If there is a decimal in the divisor, we've got to move it out of the divisor. And we must move the decimal in the dividend the same amount of times we moved the decimal in the divisor. Okay, so once we start moving it in the divisor, oh boy, that just dropped. You may be experiencing. Okay, here we're back because it was saying I was something going on my audio. So once we move it in the divisor, we now got to move it in the dividend as well. Okay, so that's the rule. Okay, so that's why we had to learn the language of divisor, dividend, and quotient because that's how we, describe the steps. Okay.
Muted. Unmuted.
Hello, hello. Can you guys hear me? Okay, great. Okay, so we're back. We're back in business. All right, yay, I'm back. All right, so that's that part of it. Yes. Sometimes the system acts weird. Okay, okay. All right, so here we've got this 2.17 and the 4.82. So what we're going to do now, we said up front, you can't have a decimal in the divisor. And we know that number on the outside is the divisor, so we've got to move that decimal. So we're going to move that decimal 2 places to the right. And then that's going to give us 217 because we moved it right to the end of the divisor. Now, if we moved it 2 places in the divisor, now we got to move it 2 places in the dividend. So when we move it 2 places there, that's going to give us 482. Okay, so that's how we go about solving the problem. Okay, now we got one more last step, and that last step is, if I can get away from this pen, add back to the arrow. Okay, all right, let me see if I can get to it. Oh wow. Hmm. Okay, so let me see if that did it. Wow. Using. Right, so here we go. All right, so the last step is going to be um, the decimal. Let me spell it right. The decimal and the dividend must be lined up with the decimal and the quotient. Okay, so that's our last step. Okay, so we're gonna go back. Okay, so that's our rules. Okay, rule number one, we can't have a decimal in the divisor. Okay, rule number two, if there is a decimal in the divisor, it's got to be moved out. Rule number three, the same amount of places we move the decimal in the divisor is the same amount of places we move the decimal in the dividend. And then finally, rule number four, the decimal in the dividend and the decimal in the quotient must be lined up. Okay, so that's our four rules. Okay, that's what we're working with when we're dividing decimals. Okay, and so we're going to go through and just kind of triage that and look at each of these problems. And as we go through each of these problems, uh, that's what's going to drive that process. Okay, so when we look at this first one here, okay, is there a decimal in the divisor? No, that's right. Okay, so we can skip rules 1 and 2 and 3, okay, because there's no decimal in the divisor. So we don't have to move a decimal in the divisor. And we don't have to move a decimal in the divisor. We don't have to move a decimal in the dividend either. So we can skip that rule. So all we do is we just go ahead and we set up our long division. We just have to simply worry about rule number 4, which is making sure that the decimals are lined up. Okay, right here. Okay. Now, there's one other rule I forgot about. Okay, and that rule is once we use a number behind the decimal in our dividend, okay, we know what the dividend is. This right here is the dividend. Okay, so once we use a number behind the decimal in the dividend, then the dividend, then we have to start placing the numbers in the quotient behind the decimal. Okay, so once we use a number behind the decimal and the dividend, we have to start placing the numbers behind the decimal and the quotient. Okay, and the quotient is our answer. Okay, so when we start this process, let me clean this up, clean it all up, go right back to it. Okay, so here we go. Okay, so we've got 2 divided by 1. Okay, and so we say, well, how many 2's can you take out of 1? Well, we can't take any 2's out of 1. So that's going to be 0. So then we're going to multiply, because remember we've got those 4 steps for division. Divide, multiply, subtract, and bring down. And then we also got the rules for dividing decimals. So we got 2 rules at work. We got the rules for long division, and then we got the rules for dividing decimals. Okay, there are 5 rules for dividing decimals, and there are 4 rules for long division. Okay, so the truth be told, that's why a lot of people just like to take a calculator to these dividing decimal problems, because you got a lot of rules to remember. Okay, so since we can't divide 1 by 2, we'll put a 0 there to say 0 means none. And then we're going to go 2 times 0. Okay, that'll give us 0. And then we'll bring 0 minus 1 will give us 1. And then we'll bring down the 1. And then that'll give us 11. And then, you know what, let me do that on the side here because they skipped that part. But the 0 is put up front, but it got skipped in this process. Because I want you guys to see what I'm talking about. That's the nice thing about being a teacher. You can do what you want to do. All right, so so I'm saying how many 2's can I take out of 1? 0. So then I'm going to go 0 times 2 is 0. Okay, that's the multiplication. Then I'm going to subtract next because that's that third step. That's going to be 1 minus 0 is 1. Then I'm going to bring down the 1. Okay, at that point right there, that's going to be 11. Okay, then I'm going to ask myself, well, how many 2's can I take out of 11? Now, once I brought that down and started using that number right there, every number in the answer goes behind the decimal because I used a number behind the decimal in the problem. So since I used that 1, now everything's got to go behind the decimal because that 1 was behind the decimal. So at that point, now I got to say, well, I brought that down. So okay, I'm going to go, how many 2's can I take out of 11? I can take 5 out. And then 5 times 2 is going to be 10. Then I'm going to subtract again. That's going to give me 1. Then I'm going to bring down the 6. Okay. And then I'm going to ask myself, how many 2's can I take out of 6? That's going to be 8. And then that's going to be the answer. Okay, they put their stuff right on top of mine. But we still came up with the same answer of 0.58. Okay, so that's the process. All right, so what I want you guys to do is I want to see if you guys can solve that second problem without using a calculator. Okay, we come up with some pretty fast answers here. 5.9. Okay, Norma came up with 5.9 as well. Okay, Joel has the same thing. Okay, so let's look at the process. Okay, we're going to use long division. Okay, then we've got 23 here. So we can take 5 4s out of 23. Then we multiply. 5 times 4 is 20. Then we subtract. 23 minus 20 is 3. Then we bring down. Then that's 6. So now we've got 36, and we're dividing that by 4. Okay. How many 4s can we pull out? 36? 9. And then we multiply. 9 times 4 is 36. And then we subtract. Okay. Remember, when we're doing long division, the 4 steps are always divide, multiply, subtract, and bring down. Okay. Okay. Now, before we move on to this problem right here, I want to do a conversion problem. I said I wasn't, but now I'm going to go back and do it. Okay. Let's say we've got 58 inches. And we want to know how many feet that is. Does anybody know the conversion rate from inches to feet? Okay, so what is the conversion rate? Okay, that is correct, Sean. It's 12. Okay, so it's 12. Okay, so in order to convert these inches to feet, we're going to have to use that conversion rate of 12. Okay, so what that means is now we got to use long division. Okay, now this is why the calculator is not going to work, because let's say, for instance, we want to convert to feet and inches and not just convert it to feet. So we're going to take 12, and then we're going to divide 58 by 12. So we got to use the long division. Okay, and so we're going to say, well, okay, how many 12s can we pull out of 58? If we pull out 5, that's going to be 60. That's too many. So we can try 4. That's going to be 12 times 4 is going to be 48. So we're going to subtract out 48. And then we're going to be left with 10. Okay. Now, uh, when we're working with the customary system, we can stop right here because our conversion is going to be 4 feet and 10 inches. Okay, so because we got a remainder of 10 inches, that's how many inches is left. Okay, so that's our answer, 4 feet and 10 inches. Okay. Now, if we put this to the calculator, and we're going to do it, we're going to put it to the calculator and see what the calculator says. We're going to take 58. Somebody take 58 and divide it by 12. Okay, so when you took 58 and divided by 12, what did you guys come up with? That's right, Jared, 4.8333. Okay, so 4.8333. Okay, so um you can't say 4 feet and 8 inches. Okay, because we know it's 4 feet and 10 inches. Okay, so that's why we have to know the steps for long division when we're using conversions. You'll see that in the assignments that we're working on, and you'll want to be careful with that. Just don't hit the calculator and trust the calculator for the answer. All right, so now we've got a little bit more challenging problem. Can anybody tell me why this problem right here is more challenging than the problem we just looked at? Why is this one more challenging? Excellent, John. There's a decimal in the divisor. That's what makes it more challenging. There's a decimal in the divisor. And what does that mean? What does that mean for the work we got to do? That's right, Jared. We got more steps. We've got to take that decimal out. Yep, you're correct, Priscilla. We got to move the decimal. Thanks, John. So that means we got to move the decimal. Does anybody know how many places we got to move that decimal? Okay, Priscilla's saying 2. What does everybody else think? Okay, 1. Okay, so we're going to move it one place. So we're going to move it one place here, and we're going to move it one place here, and then that's going to give us this right here, 45.6 divided by 4. Okay. It's okay to have it in the dividend, it just can't be in the divisor. Okay, it can't be in that number we're dividing by, but we can have it in the dividend. Okay, so that's okay. So there we go, we move it. And so now we've got 45.6 divided by 4. And then we're going to do our steps for long division. Okay, it's a good thing to practice it now because when we start working with conversion rates, we're going to need those 4 steps for long division anyway. Practice makes perfect. We'll go through the steps. How many 4s can you take out of 4? We can take out 1. We'll multiply 4 times 1. That'll give us 4. Then we'll subtract. 4 minus 4 is 0. Then we'll bring down to 5. And we'll start the process all over again. How many 4s can we divide out of 5? We can divide 1 out. Okay, then we'll go 1 times 4 is 4. Then we'll subtract again. 5 minus 4 is 1. And then we'll bring down. Then we'll start the process all over again. We'll divide. How many 4s can we divide out of 16? We can divide out 4. Okay, and so we'll say that's going to give us 4. And then we're going to say 4 times 4 is 16. And then 16 minus 16 is 0. Okay, so now we're finished. Notice the decimals are lined up. Okay, once we pull that 6 down, that last 4 went behind the decimal. Okay, does anybody know why that last 4 went behind the decimal when we pulled the 6 down? Excellent, John. The 6 was behind the decimal. Okay, so once we went to the 6, which was behind the decimal, and pulled it down and used it, then the next number that went into our answer had to also go behind the decimal. Once you start working behind the decimal, you got to stay behind the decimal. Okay, so that's the trick. Once you mess with any numbers behind the decimal in the problem, you got to stay behind the decimal in the answer. And needless to say, those decimals still lined up. Okay, so now we just kind of want to talk about a few decimals, terminating versus non-terminating decimals. Terminating decimals are decimals that end. Non-terminating decimals, we got 2 types. We got the ones that repeat and go on forever and ever, and we got the ones that don't repeat, and they go on forever and ever too. Does anybody know one of the most famous uh, decimals that does not repeat and it goes on forever and ever? Excellent, pi. That is correct. Pi is one of those non-terminating,
Muted.
Hello, can you guys hear me?
Unmuted.
Okay. Okay. So now, does anybody know what day we celebrate Pi? Yeah, that's correct, Sean and Julie. March 14th. Okay, March 14th. And, unsurprisingly, March 14th is the third month, the 14th day, 314. So that's why we celebrate pi as March 14th. So and we call pi an irrational number. So non-terminating, non-repeating decimals are irrational numbers. Now pi is not the only irrational number we have. We got the square root of 2, the square root of 3, square root of 5, also the square root of 6, and we've got e, which is Euler's number. So if you ever have to deal with continuous compounding interest, you'll come across e. Okay, percent. Okay, next concept, we're dealing with percents a lot. And Alex, okay, this is an Alex pi. Percent means per 100. Okay, per 100. It means out of 100. Okay, so that's what percent comes from. It comes from the same word as century, which means 100. We're not going to do that. Okay, so moving converting a decimal to a percent is quite easy, and then converting a percent to a decimal is the same way. Okay, so what I want to do is just kind of look at one. Okay, so let's say for instance, we've got like point 34. Okay, 3400. Okay, so what percent is that going to be, guys? Okay, 34. That's right. That's going to be 34%. Okay, and why is it 34%? Okay, okay. Multiply by 100, definitely the right thing to do. Sean, multiply by 100. John, also correct. Move the decimal two places. Now, okay, now if we were talking about percent in terms of fractions, we could say 34 out of 100. Okay, but if we're talking about converting it to percent, okay, we can do it two ways. Um, as John said, we can move the decimal two places to the right and come up with 34%. Or we could do what Sean said. We could take 0.34 and multiply it by 100 and come up with 34%. So we could do it either way. Okay, so both of those are going to give us 34%. Okay. Well, what if we had 72% and we wanted to convert that to a decimal? Okay, how could we convert 72% to a decimal? Okay, and how will we reverse that? Okay, excellent, Norma. We're going to move the decimal two places to the left. So we've got 72%. We're going to drop the decimal, we're going to drop the percent. Then we're going to take that decimal and move it two places to the left. So it's going to be back here. We're going to move it two places to the left, and then that's going to be 0.72. Now, what's another way we could do it? Okay, because we know there's a few ways, because John and Sean showed us that when we were working with converting decimals to percents. So what's something else we could do to convert it? That's right, John. We could divide it by 100. We could divide it because 72% in terms of a fraction means 72 per 100. Okay, and every division problem, every fraction is also a division problem. So when we divide 72 by 100, that's going to also give us 0.72. Okay, so those are the two ways we can do it. We can take the percent, convert it to a fraction, 72 over 100, because percent means per 100. So that's 72 divided by 100, and then that's going to give us 0.72. Okay, so we're going to clear that. Okay, and then here's an example. We got three of them at work here. We can see how they're being converted. Okay. Okay, so the next thing, converting decimals to percents and fractions. We want to express a percent and as a fraction. Okay, so we're going to convert it to a percent. We'll move the decimal two places to the right, or we'll multiply it by 100. Okay, and then when we express it as a fraction, we put it over 100. Okay, and then we're going to do the same thing with the 9.23. We're going to move the decimal. We're still going to move it two places to the right. Okay, even if the answer looks crazy, we don't care. Our job is just to follow the rule. Two places to the right gives us 923%. 9.23 or 923 over 100. We can also convert that to a mixed number. Okay, so if we forgot the rule, we can just think of money. Okay, so money will help us to understand percents and decimals. okay, in terms of a dollar, because all of your like change can be looked at in terms of percents, decimals, and fractions. Okay, now let's look at some problems. Okay, I'm going to do this first problem for us, or kind of talk about it. It says if you're going to give 15% tip for a total of $20, how much money will you leave for a tip? Okay, now there's a key word in here. We haven't talked about that word. Okay, so I want to look at it. Okay, of course, the headline kind of gives us a tip, kind of gives us a heads up of what we're looking for. That word is of. Okay, does anybody know what that word of means? That's correct. It means to multiply. Okay, so that word of means to multiply. So we have 15% of 20. So really what we're saying is 15 times 20. And then that'll tell us how much the tip is. Okay, yeah, and Vandalia is showing us another formula that we actually do use a lot. Is over of equals percent over 100. Okay, so we do use that formula when we're dealing with more complex problems. Okay, and so that word of means to multiply. And so we got 15% times 20, and then that gives us $3. Okay, so now that word of means to multiply. We're going to see another word off later on, and that word off is going to mean to subtract. Okay, so we just want to know there's a difference between the two. So we're going to leave $3 behind. Okay, so I want you guys to do this one. What is 15% of 35? Okay, so we've got a lot of responses at $5.25. Okay, and once again, what is the key word that tells us what operation we need to perform? That's correct, Julian, Cassidy, and Brasilia. That's of. So of is that key word that's going to let us know that we're going to be multiplying here. Does anybody know what that word is tells us to do? What does is tell us to do? So if you see that word is, okay, that's correct, John. It means equal. So when you see that word is, it means equal. Okay, so we got 15% here. What does the word what mean? When we see that word what, it means to solve or, okay, John says no clue. Quotient, okay. How much, okay. And then Sean says X, okay. And what is X, Sean? It's a variable, that's correct. So what is the unknown? Okay, and X is the unknown. So we can call it X or we can call it N, but it's a variable. Okay, so when you say what, you don't know what it is. That's why the question is being asked. So what is going to be N or X? Okay, and so that's the way it gets done. Let me get my writing out of here because I was just wanting to show us how it's done. Okay, so here we go. I'm going to draw down to it from here. What? Boom, 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 and there. All right, so everything's been deciphered. Um, this is actually a strategy for solving word problems. One of the strategies is we get to translate the English to math, okay, because math is a language. And so now we're ready to multiply, and you guys did an excellent job on this problem. What is equal to 5.25? Or we can simply say n is equal to 5.25 because what is a variable? Okay, this is that formula that Vandalia talked about, where we simply use is over of equals percent over 100. Now we use formulas a lot in math, okay, because formulas are patterns that we've recognized, okay, and so when we see something coming and we know that it's coming, then that's a pattern, and so we use a formula to reach the outcome, uh, that because that formula can tell us, what it is. Like if I was saying 5, 10, 15, 20, well, somebody's going to figure out that pattern that I'm counting by fives. And so I stopped at 20, but you can keep on going from 20 to 25, 30, 35, and 40. Well, that's what this formula is for. It's going to help us to figure out the answer in a more uniform way. And so the formula is going to be is over of equals percent over 100. Okay. Now the formula works great when you remember it. Okay, because that's the key with a formula. You gotta remember it. Okay. What some people do is they have like a formula sheet. They write all those formulas down, and then that way, you don't have to go back and say, well, after Labor Day party and stuff, what was that formula again? Okay, so here's the problem. Now, when we look at this problem of 200, so of is equal to 200, is going to be 100. So is going to be 100. Okay, because it is 100 comes out the is. 200 comes out the of, so that's going to be there. Now, it says what percent. So the variable in this case is going to be the percent because that's what is the we don't know what the percent is, so it is the variable. So in this case, that will be the n in this case. So we'll put an n there. Okay, so that's the way this problem will work out. Okay. And instead of using n, they used x. Okay, which is fine. Okay, now from here, we can work this as two ways. We could take 100 over 200 and simplify it down. And then we can see that we're talking about half of it. So we could say that x is going to be half of 100, which is 50. Or we can cross multiply. Okay, so when we cross multiply, we're going to say 100 times 100 and 200 times x. Okay. Okay, so when we go 100 times 100, that's going to give us 10,000. And then 200 times x, it's going to give us 200x. From here, we'll divide both sides by 200. Okay, and then that'll give us 50. And so our correct answer is 50%. Okay, so our correct answer is 50%. Okay, you guys see if you can do this one. 40% of what number is 2? You guys got to figure out which one is going to be the unknown. Okay, so Terry and Cassidy have 5. And we're saying that of is equal to 5 because we're saying that of is the unknown. Okay, how's everyone else coming with this problem? Okay, so Norma has 4. Okay, so we got a little bit more time. You guys take your time. Okay, it's never a good idea to rush in math. Never a good idea. Haste makes waste. Okay, Julie has 5. Okay, how about everyone else? And Tori has 5 as well. Okay. All right, so what we're going to do now is we're going to look at this problem. Okay, now we know we got this formula here. We've got is over of equals percent over 100. Okay, now we've got 3 variables, is, of, and percent. 100 is a constant term. That means it stays the same. It's not uncommon for us to see that in formulas. Okay, let's say if we had a formula like P equals 2L plus 2W. Okay, so in this case, the 2 is a constant term. The 2 doesn't change. It's always in the problem. It always gets worked out with the math. Here's another formula that we'll see. This is a compounded interest formula. We'll have P times 1 plus R over N. Make sure that's an R and not an N. Raised to the N over to the T power. Okay, so these are formulas. Notice that we got constant terms like 1 in there. Okay, and a constant term is a number, so it stays the same. Okay, so that 100 is always going to be 100. That's going to be one thing that's not going to change. Okay, these other variables, the is, the of, and the percent, they will change or we will have to find them. Okay, so what is the percent in this case? It's 40%. Okay, they're giving it to us. So we can take out the percent and put 40 in its place. Okay, now what is the of? The of is what number? Okay, now we said what number is a variable. Anytime you see that word, what number, that's a variable. So what is of? Of is a variable. It's an unknown. That's why we're saying of what? So of is a variable. So we can take of out and we can put n in its place or x. And then we can see is 2. Okay, so that's going to be our problem. We're going to have 2 over n equals 40 over 100. Okay, now let me ask you a question. Now that we've used the formula and we've we've added all the values into the formula, the only value that we didn't have to add is the 100, because the 100 is a constant term. It's always there. That's why we call it constant, because it's always there. The 100 is always there. The 40%, they told us it was 40%. They said it's 40% of what? So of is unknown. That's why the word what means unknown. Hence the variable. I think Sean told us that. And is 2, because the 2 followed the is. Okay. What math concepts can we use moving forward to solve for n? Cross multiplication. Excellent, cross multiplication. So we can use cross multiplication to finish this off. Okay, so we can multiply here, then we can multiply here. Okay, so a lot of you guys came up with the right answer, and that was excellent. So we came up with 40n, and then 2 times 100 is 200. And then we divided both sides by 40, and you guys know what that's going to be. And it's going to equal 5. So excellent job, my 5 people. Okay, so n's going to equal 5. Okay, now, so that's the best way to solve the problem. I mean, it's a formula. You use the formula. You do it that way. Okay, so that's if you want to use the formula. Let me Chris out of there. Okay. Another way I can do this problem is I can just go ahead and start underlining things of what number is and 2. So I can say, okay, that's 40%. Of means to multiply. What number means n. Is means equal. And then that's 2. Like that. And so 40% is going to be 0.4 times n, which is 0.4 n, equals 2. Then I can divide both sides by 0.4. And then now we know what the rule says. Okay. Okay, now when we're dividing like this, 2 divided by 0.4, what does the rule say about dividing decimals? What does the rule say about dividing decimals? We just talked about that rule today. Okay, and then we'll get to David's question. You got to move it. Excellent. That is correct. Bandelia and Norma and Priscilla, we've got to move. So we got 2 moves to make, don't we? We got to move here, and then we got to move here. So that's going to give us 20 divided by 4. Okay, not a problem, David. I understand. No, you won't. I'm going to send out a recording, okay, of this go-to training, okay, because you're registered for it. You'll get a recording of it in your email. Okay, feel free to watch the rest of it at your own leisure. Okay, so we got 20 divided by 4, and then that's going to take us to 5. Now, needless to say, we got a calculator. We don't have to do all that moving around. We can just go straight to our calculator and just say 2 divided by 0.4. And then that's going to give us 5 too. Okay, so this is two different ways of solving this problem. Okay, typically in math we have multiple ways of solving a problem. Uh, I'll post it on the announcement board. Yeah, I'll post it on the announcement board, so you guys will see it there. If you're in my class, it'll show up on the announcement board. Okay, you're welcome. Have a good day, David. Okay, so this is the second way of doing the problem. So if you hate that formula, if you're looking at that formula and say, God, this formula sucks, okay, uh, you can go back to doing it the old way where we decode the English into math. And you can do it either way. Okay, the more you know about math, the less work you do, and the more options you have. Okay, you become like puppet master. You can, or like ninja, super ninja, you can, you know do problems multiple different ways and avoid stuff, and kind of like stealth bomber, go in there and do something that no one ever seen before. Okay, that's why it's so important to learn as much as you can about it. Okay, let me get rid of all this, and then because I want the PowerPoint. Okay, so we see the is and the to. Okay, of what number is a variable? There we go. Cross multiply, divide. X is 5. Okay, 40% of 5 is 2. Okay, so here's one more. You guys see if you can do this one. Okay, practice makes perfect. The more we practice, the better we get. Okay, Julie has 12. Okay, give me your answer and tell me what method you used. Did you use like the formula, or did you use an equation? So I want to know, your answer, and then I want to know what method you used. Did you use the formula, or did you use the equation? Okay, so yeah.
Muted. Unmuted.
Okay, cross multiplication is the formula. Okay, so those who cross multiply, use the formula. Okay, anybody use the equation? Okay, John said he used common sense. Good joke. Okay, so did you use the formula, or did you use the equation? Okay, formula. And I just like to know from my preference, what students favor. I mean, it really doesn't matter. I mean, you know, what we're showing you at the end of the day, math is just a tool that we use to make better decisions. Okay, math is a tool that we use to figure out how to manage our money, how to pay bills, how to make money, you know, how to save time. Okay, how to manage our health. Okay, how to do our jobs. Okay, so at the end of the day, math is just a tool. Okay, and Samuel B. Gruder, which is a famous math professor, stated that the essence of math, okay, is to take things that are complicated and make them easier to understand. Okay, we shouldn't be taking things that are easy and making them complicated. Okay, so that's the process. Okay, yeah, yeah. When we finish this one, Julie, then we'll address your assignment one question. Okay. Uh, Two ways to do this. Okay, we got our formula. Okay, three is, 25% is given, of is unknown, because you got that word of what number. Okay, we cross multiply. Ugh, they didn't cross multiply. we'll cross multiply it out. 3 times 100, 300. X times 25, 25x. And then we divide both sides by 25. And then at the end of the day, x equals 12. So you guys were super. Okay, we want to do the equation part because Julie has an assignment 1 question. So we want to go ahead and address that because I know assignment 1 is coming up. Okay, in fact, we got about 30 minutes left. Let's use those 30 minutes to address any questions that you guys have about assignment 1. Okay, so we'll do that. Okay, so I'm gonna clear the board here. So I'll have writing space clean. Okay, so Julie, what's your question about assignment 1? Okay, so let's see, you're saying if there's a 32% discount on the budgeted trip, what is the actual transportation cost? Okay, so I'll give you a similar problem. Okay, let's say you got a budget. Let's say you got a budget and you budgeted $70,000. That's your budget, 70,000. Let me look at your question. $70,000 what you budgeted for transportation, but you're gonna get a 20% discount. Okay. Now, now that discount is an off problem. Okay. Of means you just multiply, but off means you gotta subtract too. Okay. So this problem can be done two ways. Okay. But no matter which way you do it, you're gonna have to subtract. Anytime you get an off problem, you're gonna subtract. Okay. If we're gonna take 15% off your grade, we're gonna if you got 100, it's gonna go 100 minus 15 is 85. So anytime you see the word off or discount, subtraction is gonna be involved. So okay, so I'm gonna say you're gonna get a 20% discount. Okay. Now I'm gonna show you the first way, and then I'm gonna show you the second way too, and I'm gonna tell you why both ways work. Okay. So what we're gonna do is we're gonna say 70,000 times 20% times 20%. Okay, you can take that 20% and throw it in your calculator because it's a word problem. And that 20%, obviously that 20% got to get moved. The percent gets dropped and the decimal gets moved to the left. And then that's going to be 70,000 times 0.20, which is going to be 14,000. That's the discount. Now remember we said subtraction got to be involved in this problem. So we're going to take 70,000 minus 14,000. Okay, and when we do that, that's going to give us 14,000, 56,000. Okay, so that's one way of doing it. Okay, but now mind you, subtraction had to be done. Okay, because the word discount means the same thing as off. You got 20% off. Okay, and that's the key word. Remember, I said that there are two words that we're going to be looking at. Of means to multiply. Okay, off means to subtract. Okay, and so you got to be able to distinguish when you see these two words. in word problems to know that you're going to be subtracting and multiplying. Okay, now from here, we're going to go ahead and do it a different way. If you're getting 20% off, that means that out of 100%, we're going to subtract 20%. Okay, let me put a multiplication sign here. So that means if you're getting 20% off, you got to pay for 80%. That's what it means. You're getting 20% off, you got to pay for 80%. So you got 70,000. And then 100% minus 20% means that you get to pay for 80%. So then from there, 70,000 times 80%, that's going to equal 56,000. So you got 56,000 still. But now notice no matter which way you did it, that off word means subtraction is involved. Okay? So that off word means subtraction is involved. All right, so that's what that problem means. Okay, now budgeted is what you're expecting to pay. Okay, a budget is an estimate. Okay, we have, like, say for instance, if you're gonna go out and buy a car, you may budget for 30,000 or 40,000. Okay, but that's what you're wanting to pay. That's not gonna be the actual cost because I mean, even though you got some say, the person that's selling the car got say too. Okay, and so that's where we come in from budget versus real or budget versus actual. Okay, so that's that type of question that we see, and I think that's one of those 5 questions at the bottom of the assignment. Does anyone have any questions about the conversions or any of the other assignment one uh, problems? Okay, Vandalia, what's your question? And then we'll get Norma's question. When you say what equation would you use to solve them, when you're talking about them, are you talking about the conversions or the increases or the decreases? But which problems are you talking about on the assignment one? Oh, the first set? Oh, you're talking about where it's increasing by 24%? Okay. Okay, I'll do two of those for you. I'm going to do one with the customary, and then I'm going to do one with the metric. Okay, let's say you have, say, like 9 feet. Okay, so you got 9 feet, and then you've got 7.2 meters. And we're going to increase both of these by 24%. So both get increased by 24%. Okay. Now, the way we increase by 24%, we can do it two ways. I'm going to show you the quickest or the fastest way to do it. Okay, so the fastest way to do it is just to multiply by 1.24. Okay, and then this one's going to get multiplied by 1.24 too. So that's the fastest way of doing it. Okay, now, where did the 1 come from? The 1 represents the 9 feet, and then the increase is the 0.24. So that's where the 9 came. That's where the 1 comes from. The 1 stands, so when you go 1 times 9, it's going to give you the 9. And then you just multiply 0.24. So if you go and do it, you're going to say 9 times 1.24. And we'll multiply it just like we normally do. In fact, what I'm going to do is I'm going to flip it around. And then because I want to do it manually, but I don't want to do all that 3 multiplications. I want to just multiply it by 9 once and be done with it just one time. 4 times 9 is 36, carry the 3. 9 times 2 is 18, plus 3 is 18, 19, 20, 21. And 9 times 2 is 11. Okay, there are 2 numbers behind the decimal in the problem. There are going to be 2 numbers behind the decimal in the answer. Okay, so that's going to be 11.16. Now that's 11.16 feet. Guess what? We're not finished. So in order to finish this problem, we've got to still convert it to inches, okay? Because they don't want just 11.16 feet. They want feet and inches. So we know we got 11 feet because that's the whole number. So we're going to say 11 feet. And then to figure out the inches, we're going to go 0.16 times 12. So we got 0.16 times 12. That's going to give us 1.92. Now that 1.92, I'm just going to round that up to 2 inches. Okay, so that 1 point. Now, does anybody know why I'm multiplying it by 12? Does anybody know why I'm multiplying it? Right, because there's 12 inches in a foot. So I'm going to go, that's going to give me, so that gets rounded up. And I'm going to put an approximate sign there. So that's going to be, notice it's wavy and it's not solid line. So that's going to be 2 inches like that. So at the end of the day, we got 11 feet and 2 inches. Okay, so we got 11 feet and 2 inches. So that's the answer when we're using the customary. Now, the customary is going to tell you to do it that way. It's going to say, you know, uh, give your answer in terms of feet and inches. So even when you multiply and you come up with that decimal, you can't stop at 11.16. Because if you stop at 11.16, then, all of the math professors have been told to mark that wrong. And they're going to mark it wrong, because they've been told to do that. So you got to convert that 0.16 to inches. So it's going to be 11 feet and 2 inches. And that's what they're going to be looking for. 11 feet and 2 inches. And make sure that you have the unit of measurement are feet and inches. Make sure that you have both of those. Don't just put 11 and 2, because that'll get marked wrong too. It's got to be put 11 feet and 2 inches. Okay. Now, the meters is going to be a whole lot easier. Okay, we're going to just go 7.2 times 1.24. Okay, and on that one, when we multiply, that's going to give us 8.928 meters. Okay, now with the meters, they tell you to round to the nearest hundredth. Okay, and so that nearest hundred is where the pennies are normally at, right there. So when you round, it's going to always look like it's money. So you're gonna look at that too, and then you're gonna look at the 8 behind it. The 8 is 5 or higher, so it's gonna get rounded up to 8.93 meters, like that. Okay, and so that'll be your answer in terms of meters on the increase. 8.93 meters on the customary, 11 feet and 2 inches. Okay, so we had a question from Norma had a question. Okay, so Norma, what was your question? Okay, so my problem is how to work out percentages between two very large numbers. This would, if it's an is of type of problem. If it's an off problem, it's not. Okay, so that's the key. I would have to see, what type of problem it is. Okay, but if it's like, you know, um, right. So like if it was like 750% of what number is 84, then yeah, this would work. Let me clean this up. Okay, so let's say we had something like uh pen. Let's say we had 250% of what number? What number is 160? Okay, so with this problem, these are big numbers, but we're still going to use the same concept. Okay, and so we're just going to underline the stuff of what number is 160 and 250%. So those are the things that we know. Okay, now we got three things underlined because the 100 is constant. Okay, so we don't need to know that it's always the same. All we're looking for is of percent. And we got those three things underlined. Okay, so you see we got those three things underlined. The 100, we don't have to worry about that. That's always the same. So we're just going to fill in the stuff that we have. Okay, so when we start filling in 250%, so we're just going to say 250. And then that's going to be over 100. Okay, because it's always over 100 no matter what. And then we're going to put in of what number. So of is unknown, so we're going to call it n because that's what the word what means, of what. And then is 160. So is 160, is 160, like that. Okay. Now from there, we're going to just cross multiply. 250 times n is 250n. And then we got 160 times 100. Okay, so then that's going to give me 250n. Then I'm going to use a little shortcut that I know of. There, 100 has two zeros in it, so I'm going to go 160 and add two zeros to it, like that. Okay, so now that's 16,000. Okay. Um, 16,000 is probably going to give me about 400, but I'm going to throw it in the calculator anyway. So I'm going to go 16,000 divided by 250. Nope, it gave me 64. So n is 64. Okay, so my final answer is 64. So 250%, 250% of 64 is 160. Okay. Okay, so that's your answer. All right. Any other assignment one questions, or any questions about the math anxiety discussion question that came up? Okay. One of the things I want to do for you guys, I'm gonna give you guys as soon as I pull it here, I'm gonna give you guys a APA app. It'll actually, if you put all your information in, it'll actually format in APA style for you. So let me see if I can find it in my full cell box. Uh, where's the thing at? Planning, education tools. Okay. Almost. It's not there. Where is it at? Maybe it's in my education down here. Tools and resources. Scholarship. Ugh. Let me see. All right, let me do this because this is a really good tool. I want you guys to have it. I mean, if you're in my class, you already got it. Okay, not a problem. You can pick up the app because I'm gonna put it in here in a second, but you can pick it up in the recording. Let's see. Mm, it's a really good app. Let me click this thing. Okay, let's see. Okay, it's a citation machine. It'll cite anything like for the discussion questions. I mean, you just put the information in for your journal and stuff, and it'll cite it for you in APA style format. Copy. All right. All right. So there you go. All right. So that's it right there. So, um, when you're doing your discussion questions and you need to cite things, like if you put whatever journal you're doing, um, like I don't know, let's say for instance, um, let's say math aid empowering or something, and then go search for journal, and then I can see if there's one in here already, it'll have it for me. Like let's say for instance, if this is it, then I can just select it. If it's not in here, then I can just add the information myself in here. Um, like if I want to manually enter the stuff in, I'll just go to manual like that, and then I just have to put the name of the author right in here, and the article title, volume, all that kind of stuff. If it's a journal, if it's a website, I just click the website like that and do manual mode and enter my information here. Okay, and so that'll help you out. The reason why I want to share that with you guys, because as I'm grading discussion questions, I'm noticing that a lot of people are missing those 10 points because it's really an all or nothing situation. Okay, so it is 5:55 now. Okay, we're getting ready to close out this go to training. Does anyone have any more questions for me before we call it a day? Okay, you're welcome, Vandalia. You have a great day too, Norma. Okay, likewise, Jennifer. Okay, guys, if no questions, and you're welcome to, Terry. It was nice having you in this session. You guys have a great one. If you got a private question and you just want to stick around and ask me about it, feel free to do so. Thanks, Cassidy. If not, I'll see you guys later. Okay, yep, sure, Joel. Feel free to do that. Alrighty, Priscilla. Okay, Rebecca, do you have any questions for me? Okay, if not, I'm going to go ahead and close out this discussion question, this go-to training.